Good evening, students. Good evening. Good evening. How are you, dear students? Yes, very good. I am also fine. And expecting that you are doing very good. Whatever topic till we covered, I think you have revised these topics well. And still not revised, please revise all those topics. Otherwise, physics is the subject. Such a subject you can say, if you are not revising the subject, that means after 10 to 15 days, after you will find that yes, you don't know anything in that particular topic. That's why keep revising, and especially you can say numericals you need to solve. Okay, dear student, let us start. So yesterday we have discussed about unit and dimensions, and today we are going to continue that part only, and that is very, very important. You can say complete summary of physics in this single chapter. Whatever physical quantity we are going to discuss in your first year and second year syllabus, all that physical quantity we are going to discuss in this part. Okay, dear student, let us start this. So till now what we have discussed, yes, in yesterday's class we have discussed there are 7 fundamental quantities. What is that? M, L, T, then A, Kelvin, yes, very good, then after mole and candela. By using these 7 fundamental quantities, we can derive some quantities, yes or no? These are called derived. These are fundamental, yes or no? Fundamental quantity. That we already discussed. Now our topic is how to form dimensions by using these fundamental quantities. Means our task is to, what is the task? Whatever quantity dimensions we want to form, we have to write that quantity in the form of fundamental quantity. Like we have discussed. Okay, let me revise. You tell me first, what is the dimension of force? That is very important. Again and again we have to use it. M1, L1, T minus 2. Yes or no? What is the dimension of work? This is M1, L2, T minus 2. What is the dimension of power? This is equal to M1, L2, T minus 3. See, there is no need to memorize these dimensions. What you need to know, just you need to know that how to form these dimensions. That means you should know the formulas. Means force equal to mass into acceleration. Then after, work is equal to force into displacement. Power equal to work upon time. And all these terms, you can say divide it in fundamental quantities part, and you can write the dimensional equation. So up to here I think everything is crystal clear. Now let us move forward, and very important part, what is that? Let us I think some of the quantities still left, that dimension we have not discussed till now. So let us discuss some dimensions. Yesterday I given you some task. What is that? I think you know the dimensions of G for gravitational constant. You know the dimension of epsilon naught. Yes or no? Now let us go to the 2 and 3 part is still remaining, that we will discuss now only. For that we will try to learn how to form those dimensions, especially for magnetic field. In magnetic field, one quantity is one that is called magnetic field, B for magnetic field. That is also your second year syllabus. You tell me how to find out the dimension of magnetic field. What is magnetic field? If sometime you are confusing, you can remember one formula. Magnetic force equal to ILB. This is the single concept you can remember. That means what you need to find out? Dimension of B. Now you find out B equal to F divided by I into L. Use this and find the dimensions. Okay, let me check whether you are right or wrong. Do it fast. Okay, student, what is the dimensions? Yes, let us discuss force. Dimension of force is M1, L1, T minus 2. I stands for A, L for L1. Then it is going to be M1, L0, T minus 2 and A minus 1. This is the dimensions for magnetic field. So like that you need to remember the dimensions. This is magnetic field. See, this magnetic field Tesla, due to magnet, you know, the one magnet attract another magnet, or you can say repel another magnet due to the magnetic field. In same way, one charge attract or repel another charge. That field is called electric field. You can write. These formulas are very important. Now we will discuss E for electric field. What is the dimensions for electric field? Yeah, how to find out dimensions of the electric field? Yes, electric field means E equal to force divided by charge. You remember this formula. If you remember this, you can find out the dimensions. If you know this formula, I think you can find out the dimensions. So, try to make the dimensions of this part. Force itself is denoted by M1, L1, T minus 2. Charge is denoted by A into T. Yes or no? Then what is the dimension? M1, L1, T minus 2 in the sense T minus 3 and A minus 1. This is the dimension of electric field. That means we find out the dimension of electric field as well as dimensions of the magnetic field. So I think up to here everything is crystal clear. Okay, let us move forward. See, in one of our NEET exam, what they have asked, find dimension of E divided by B. This is exam question only, dear student. Find the dimensions of E divided by B. E for electric field, B for magnetic field. What is the dimension? You tell me fast. Because I already told you dimensions of E, I already told you dimension of B. Now put these value and find out. Yes, do it fast. When you find this dimension, you will find a specific dimension, that is dimension of velocity. You can check it, cross check. That means you can directly remember that formula, this E divided by B equal to speed of light, that we will discuss in chapter electromagnetic wave. That means sum of the quantity, which having specific form. For that we no need to find dimensions and waste our time. Directly what we can do, we know that this is the speed means velocity, and dimension of velocity is m0 l1 t minus 1. This is the dimension of velocity. You can write this dimension. Yes or no? Yes sir, we can use that and we can form this dimension. I think up to everything is crystal clear. See, I am giving you some specific formulas. These are directly used in your NEET exam. So you remember that, how these quantity refer to. For example, one quantity that is called RC. R for resistance, C for capacitor. See, if they in exam, let us assume they are asking that what is the dimension of RC. If you are going to find out, you will take lot of time, because first you will find dimension of resistance, then capacitor. It will definitely consume lot of time. That's why what to do in this types of the question, what you do, this itself is called time constant. What is this? This is the dimension of time. We will discuss in current electricity part. That's why this is dimension is M0 L0 T1. One more quantity, that is L divided by R. L for inductance. You can write down R. You know that R means resistance. Like resistance, C for capacitor, or you can say capacitance. Yesterday we have discussed. And L for inductance, that we will discuss. Inductance. See, capacitor is used to store electric field, and inductor is used to store magnetic field. Like that you can remember this. Yes or no? This is RC and L by R. These both are having time dimension. Dear student, one or two more dimensions. If I am asking you, what is the dimension of half mv square? So I think no need to find out. What is this? We know that this is energy, sir. Which energy? Kinetic energy. And dimension of energy is m1 l2 t minus 2. Because I want to tell you that sometimes examiner what will do, he will produce some questions which have some standard format, like RC dimension directly asked in our exam, L by R dimension directly asked in our exam, half mv square directly asked. So in that case, you should know this is energy. Same way, we will find one formula, this is half CV square. This itself is energy only. What is this? This is energy. One formula, half Li square. This is also energy only. Yes or no? So these are the form of energy. You can make a note of all these concepts. These are very, very important, dear student. You remember all these concepts. Yes or no? Okay, sir. Up to here, I think everything is clear and you are enjoying the subject. Okay, let us move forward. So this is energy form. Okay, that we will discuss in your second year physics. See, one more important part that is already asked in your exam. What is that? One quantity is there. This is called half epsilon naught E square. Epsilon naught yesterday we have discussed. This is electric permittivity. E for electric field, we already discussed. This quantity is called energy density. What it is called? This is energy density. And what do you mean by energy density? Energy density means not the energy. Energy density means this is energy divided by volume. Energy density means energy by volume. See, if you will find out dimension by using this formula, this is very lengthy process. You can find by this formula also, but this is very lengthy process. It will take time. That's why in your second year physics in electric field, we will discuss this quantity is energy density. That's why its dimension is like energy density, energy by volume. Dimension of energy is M1 L2 T minus 2. Volume is L3. So this is going to be M1 L minus 1 T minus 2. This is energy density. One more quantity like that only. Or in magnetic field we will discuss epsilon naught is replaced by 1 by mu naught. B square divided by mu naught. That itself is energy density. So you can remember this formula directly. Very, very important. Yes or no, dear students? Okay, sir. If up to here everything is clear, and always try to note all these concepts. These are very important because that you will be discussed in your second year physics. So these are very important concepts, very, very important. You can say you are studying what? Complete physics, physical quantities that we will going to use in further your 2-year course. So that's why these are very, very important. Yes or no? And yes, in comment box, no chatting should be there. There should be only your energy. Whenever required, only our discussion, subject relevant part, as well as, yes, whenever things are cleared, comment box should be fired with complete full of energy. That thing I need from you guys. And you don't waste your time on all the chatting and all. Yes or no? Just have a dream to be a great doctor, to take admission in the best medical college. You can say AIMS, JIPMAR. You have dream for this type of the medical college. Yes or no? And for that, long vision is required. Long consistently preparation is required. And for that, we are here. That's why listen. Whatever Sri Chaitanya group is providing. Yes or no? So I think you should be thankful for that. Okay, dear student. Up to here, everything is, I think, very, very clear. If this is clear, then let us move forward. Now, basically, we have to discuss application of the dimensions. Okay, before that, I think one part is still left about the dimensions. Which one? Heat and thermal physics part. In that, some quantities are there. What is that? You tell me, students, if I am asking you dimension of intensity. What is the dimension of intensity? How to find out this? It is denoted by I only. What is intensity? That you should know also, because in one of the chapter, that is wave. We will, wave and wave optics, in both intensity will be there. What do you mean by intensity? Intensity is basically, what is that? Energy per unit area in per unit time. Intensity means energy per unit area in per unit time. This is the intensity. And if someone asks you dimension, okay, before dimensions, you can find out energy upon time is power. So you can say this is power divided area also you can say. So what is the dimension? If someone asks you unit of the intensity, this is power means watt, area means meter square, and what is the dimensions? Let us form dimensions. You try it first. See, this is your work. The most you try to form the dimensions, most you will be comfortable in this dimension part. That's why always using your pen paper, yes, try to form these dimensions, because you know the dimension of power, you know the dimension of area. Just directly use the concept and form this dimension. What it will be? Yes, M1 L0 T minus 3. Yes, very good. Jhansi, very good. Power in the sense M1 L2 T minus 3. Area in the sense L2. That means this intensity is M1 L0 T minus 3. This is the dimension of intensity. Remember this, dear students. And what is the unit? Watt per meter square. Like intensity only, we will discuss some quantity in thermal physics, like emissive power. That means intensity, and what called emissive power. You can write also emissive power having same dimension. Emissive power is not the power that is having the dimensions of same of intensity. You can remember also. Directly we will use this. Yes or no? In spite of that part, some of the part we will discuss. That is called thermal conductivity. You know, its unit is directly asked in your NEET exam. Okay. We going to discuss two more dimensions. One is thermal conductivity and one is the electrical conductivity. So let us discuss. First you tell me what is the dimension of electrical conductivity. You find out, because that you know already. What is electrical conductivity? Electrical conductivity is denoted by sigma, or if you don't know, sigma means 1 by rho. This is the favorite part, very important for you. Find dimensions of this electrical conductivity. How to find out? Yes, please. That means you should know the dimensions of resistivity rho, then only you are able to find this dimension. For that, you know R equal to rho L by A. Yes or no? You can use this formula, because dimensions of the resistance you know that. That means can I write sigma equal to, what is rho? Value of rho equal to R into A divided by L. That means sigma equal to, what is that? L will be on upside, that is R into A. Yes or no? This is sigma. L dimension you know, A dimension you know, dimension of the resistance we have already discussed. So by using this process you can find out the dimensions of this part. Yes or no? Okay, sir. Now you find out dimensions for what? Yeah, very important. That is dimensions for thermal conductivity. Okay, dear student, what is that dimension? Tell me first. See, thermal conductivity is denoted by, this is directly exam question that is asked in NEET exam. What is that? Thermal conductivity. What is the dimension of thermal conductivity? How to find out? See, thermal conductivity is denoted by delta Q divided by delta T. That means delta Q is heat energy, that is equal to Ka dt by L. Yeah, don't be worried. Why I am giving you this formula? I know that you don't know this formula. I think nothing about this, but that you will discuss. If right now, if you only You can clearly see this formula when you discuss, or you can when you study, you will get clear idea. That means K equal to Q by T is work as the power. This is heat by time. That means this is power. So how to find out this is power into length? Now you find out this is your work. K already given divided by area, and dt means temperature. I think now you can find out dimensions of the thermal conductivity. This is the right process to find dimensions of thermal conductivity. Yes or no, dear students? Okay. I think up to this point everything is clear to all of you. Yes or no? Okay. So now let us move to the its next part. That is very, very important. But before going to that, let us have a look on some questions directly that is being asked in NEET exam. You tell me, dear student, what is this? I think this is visible to all of you. Which one of following is not fundamental quantity? Which one is not the fundamental quantity? You tell me. Which one? Temperature, electric current, pressure, or length? See, temperature is, yes, fundamental quantity. Electrical current is fundamental quantity. Length is fundamental quantity. Pressure is not the fundamental quantity. Yes or no? I think this is clear. Okay, this is clear. Then let's move on the second question. Second question is this one. Which of the following is the smallest unit? Yeah, that is, I think you know that. This is only general knowledge part. Yeah, light year is very large distance. Very large distance. I think no need to tell you. Meter, you know already what is meter. What is angstrom? Angstrom in the sense this is 10 to the power minus 10 meter. What is Fermi? Fermi means 10 to the power minus 15 meter. Now you tell me which one is the smallest. Which one is the smallest? Smallest, yeah, tell me fast. Which one? 10 to the power minus 15 meter. I think sometimes students are getting confused about the powers. 10 to the power minus 10 is smaller, or 10 to the power minus 15 is smaller? Yes, definitely 10 to the power minus 15 is smaller. Very good. That means Fermi is the right answer. Yes or no? Getting this? Okay. Let us move forward. Tell me this one. Which one of following is not a fundamental unit in SI system? This is same question only. Same concept, same question. Tell me fast. Which one is the not fundamental quantity? Ampere, unit, not quantity. Ampere, Kelvin, Candela, or Pascal? Which one of following is not fundamental? Yes, very good. Which one? Pascal. Pascal is the unit of pressure, and pressure is not a fundamental quantity. Yes or no? Okay, dear student, let us move on this question. I think about this question is specific. Which of following is unitless quantity? Unitless, I already told you. And yesterday I told you one statement. What is that? Unitless quantity always dimensionless. Yes or no? Unitless quantity always dimensionless. Is it right or wrong? Yes, right. But dimensionless quantity may have unit. Very important statement. Remember this statement, dear student. Very important. Yes, dear student, tell me what is the right answer. Which of following is unitless? Yes, I think in this one, what do you mean by velocity gradient? Velocity gradient word means divided by length. Always remember that whenever someone asking you what do you mean by gradient, velocity gradient, velocity by length. Length gradient itself is called displacement gradient. Displacement gradient means the displacement divided by length. Pressure gradient, pressure divided by length. Force gradient, force divided by length. See, which one is the dimensionless? I think this one. Displacement is also measured in meter, length is in meter. This is dimensionless, means M0, L0, T0, this is the dimensions of a, yes, this is a not dimensionless quantity. Which one? Gradient. Gradient itself is called slope, means slope itself is dimensionless quantity. I think you know that. Yes or no? Okay, now you tell me fast, what is the dimension of velocity gradient? Fast. Now your work is to find out dimension of this one. This one, find out fast, we will discuss, and this part also. Let me check whether you know that or don't know. I am giving you 1 minute time. Do it fast. I think done. Okay. Check whether you done right or wrong. Okay, I am telling you what is the dimension of velocity gradient. Okay, velocity gradient in the sense, I told you that velocity upon length. Dimension of velocity is L1 t minus 1 and length is L1. L1 going upside, this is only t minus 1. That means dimension of which one? Velocity gradient is t power minus 1. Pressure gradient. Pressure gradient in the sense pressure by length. Okay, dear student, what is the dimension of pressure? Pressure equal to force by area. Dimension of force is M1 L1 t minus 2. Area is L2. This is going to be M1 L minus 1 t minus 2. Yes or no? But divided by length also, because this is pressure. We are going to tell what? Pressure by length. So length is going upside. This is M1 L minus 2 t minus 2. Means to say this dimension is M1 L minus 2 t minus 2. Yes or no? And third one is force gradient, means force divided by length. That is force dimension M1 L1 t minus 2, and L1 main cancel this. This is M1 L0 t minus 2. This is the dimension of force gradient. Okay, tell me, dear student, those who have done all these three dimensions right, yes, they should comment with complete energy, fire. Done? Okay. Now let us move forward. Okay, if you have done this, then let us move on some other part of this chapter. I think regarding dimension, this is also NEET exam type question. Two physical quantities, which one is vector and other one is the vector and one is scalar, having the same dimensional formula. What you have to tell, there are the quantities is given in which you have to tell which one of following is vector, which one of, sorry, not which of the following should have same dimension. First of tell me all the quantity having same dimension or not. Okay, tell me what is dimension of work. You check it fast. Work and energy dimension same or different. Second, torque and work dimension same or different. Impulse and momentum dimension same or different. Power and pressure dimension same or different. That means two physical quantity, which one is the vector and one is the scalar, having the same dimensional formula are. Which one of following quantity? Tell me fast. This is good question. Exam pattern question only. Check it fast. I think in this one, if we want to check work and energy, both are scalar quantity. Dimension are same, but both are scalar. That's why this option is not right. Torque and work, you tell me about. Torque is force into this perpendicular lane. This is vector. What is this? This is vector and this is scalar. And both are having same dimension. I already told you. Torque is denoted by force into perpendicular distance and work is denoted by force into displacement. So both are having same dimension as well as per question requirement. One is vector and one is scalar. That is also true. Impulse and momentum also I told you both are having same dimension, but both are vector quantity. In question it is mentioned that one should be scalar and one should be vector. Now you tell me first this part. Power and pressure are having same dimension or different? You check it first. My question is that power and pressure. What is the dimension of power? What is the dimension of pressure? Check it whether they both are having same dimension or different dimension. Check it fast. Check it and write in comment box. Torque and work, yes, very good. I am Sudarshan, right. Some students are doing very well, but some are, yes, what they are doing, they are only chatting, some of the students. After repeating again and again that, yes, don't use comment box for the chatting, just use it for your subject knowledge only. Okay, tell me, what is the question? Power and pressure, dimensions are same or different? Different, yes. Venkat, very good. Venkat, I think most of the times I find that the student is giving right option. Very good. Different means power is work upon time. That is already we know the dimension M1 L2 T minus 3. This is the dimension of power. What is pressure? Sometime before we discuss force upon area. This is M1 L minus 1 T minus 2. That means both having different dimension. Yes or no? Both are having different dimension. You should remember this. Okay, dear student, I think this is very clear to everyone. Okay, this is clear, then can move forward. Yes. Okay, let us move forward, dear student. Now be activated. Okay, let me check whether any other questions which is relevant to this part that we will discuss in next class. This one. See, same question. Dimensions of the torque are. Which one is the dimension of the torque? Right now only I told you. Tell me fast. Some of the students still I think not listening. I want that everyone should comment right answer for this question. Dimension of torque are. What is the dimension of torque? Which one is the right option? Option 3. M1 L minus 1 T minus 1. No, wrong. Option 3. Option 3 is the right, not 2. Option 3 means this dimension is the right dimension. Torque in the sense tau is denoted by tau and this is force into perpendicular distance. And we know its dimension is same as work. M1 L2 T minus 2. That means third option is the right option in this question. Yes or no? Okay, dear student, I think this is crystal clear to everyone. Done. Okay, this is clear. Let us take some more example. Sometimes you can find this types of the question also. Which of the following pairs does not have similar dimension? Yeah, you check that condition fast. 1 minute time you can take and try to do it by yourself. Tension and surface tension, same or different dimension. Stress and pressure, Planck constant and angular momentum, angle and strain. Which of following pairs does not have similar dimension? But what you tell? Which one of following is don't have the similar dimensions? Tell me, dear student. That means 3 options are having same dimensions. Which are that you have to check. Okay, do it fast and yes, right answer in comment box. What is angle? Dimension of angle, tell me fast. And strain, I think some of students don't know strain. Dear students, strain is also our syllabus topic. Strain means change in length divided by initial length. Remember that. What do you mean by strain? Strain means change in length divided by initial length. That means, and angle means arc upon radius. So now you tell me what is the dimension? Both are having M0, L0, T0. Means both are dimensionless quantity. What is that? M0, L0, T0. Yes or no? Dimensionless quantity. That means these are one option. These are having same dimension. Okay. What's about tension and surface tension? Tell me fast. Tension means force. If don't know, tension means force. Remember that tension is a type of force that we will discuss in chapter Newton laws of motion, and dimension are same, M1, L1, T minus 2. Yes or no? So that means this is having same dimension, this having same. Let us check Planck constant and angular momentum. Planck constant, I think in chemistry you discussed that. What is that? NH upon 2 pi equal to MVR. I think you know that. In chemistry you discussed this. This is MVR itself is called angular momentum. This is called angular momentum. We already discussed in our class also. In yesterday class we have discussed angular momentum. That means 2 pi is constant, n is constant. That means Planck constant having the same dimensions of Planck constant have same dimension of the angular momentum. That means these are also having same dimension. See, this one same, this same. Stress and pressure. Stress, what's about this one? Tension and force is okay, but what's about surface tension? Still we have not discussed. You tell me what? See, tension is force dimension, but what's about surface tension? Surface tension is force divided by length. What it is? Force by length. That means its dimension is M1 L0 T minus 2. Very important. That means dimension of which one? Tension and surface tension are not same. Then right option is this one. Now one more left. Stress. Stress means force by area. What do you mean by stress? Force divided by area. And what do you mean by pressure? Pressure means force by area. Both are having same. This is very good question. Means to say you should know what is that, which one of the following, because this type of the question is already asked in our exam. Very important. So that you should know which of following quantities having same dimension and which are following having different dimensions. You can have a note of these quantities, especially those quantities which are having same dimensions, like torque, work, energy, same dimension, stress and pressure having same dimension. Any other? We have told angle, solid angle, and which one? Strain, relative density, because these are dimensionless quantity. So this and angular momentum and Planck constant, these are having same dimensions. Okay. Now tell me dimensions of the relative density. Tell me fast. I think this question should be answered by every student. This is the simplest question. What is that? Tell me. Very good, dear student. Still, which option? Yes, third option. Relative density means this is a ratio. I already told you this is the density of liquid divided by the density of water, and that means this is dimensionless quantity, means M0, L0, T0. This is the dimensionless quantity, very important. So I think most of the students are right in this one. Yesterday I discussed one, which one? Electrical resistance dimension. Tell me what is the dimension of electrical resistance. I think these options are not visible to you clearly. Okay, no problem. You tell me. I think little bit help can I do for that? Yes, I think that is not visible. Okay, this is your assignment. You will find out dimension for electrical resistance. Okay, let us do one more question. This one. Dimensional formula for gravitational constant. What is the dimensional formula for gravitational constant? Yesterday only we have discussed. Very important, very important. And yesterday told you that in NEET exam, you know, gravitational constant, most of the times they use this word in dimensional chapter. So that's why this is very important, dear students. So that means how to remember F equal to G M1 M2 divided by R square, means G equal to F R square divided by M1 M2. F dimension we know. M1, this is M2 when going up M minus 1. L1, L2 means L3. This is T minus 2. Yes or no? M minus 1, L3, T minus 2. M minus 1, L3. Which one? M minus 1, L3, T minus 2. Fourth option is the right option. Yes or no? So I think up to here, I think everything is clear to my dear students. Yes or no? In next class, we will discuss what? That is application of the dimensions. Very important topic. Last one topic, and I think tomorrow our bridge course is going to finish. Yes or no? So we will discuss that part. Okay, dear students, thank you very much. Jai Hind.